Believe it or not, there's some additional rules for sig figs. Anytime we perform a calculation, we're going to have to keep these rules in mind. I like this little cartoon. Explain significant figures to me like I'm 5.000000 years old. So kind of keep this in mind. The answer can only be as precise as the question. What I mean by that, if you're adding, subtracting, multiplying, or dividing some numbers, the answer that you get can only be as precise as the question. And why I put question in quotes, what I mean by question are like the two numbers that you're multiplying together, for example, would be the question, and the product would be the answer. So, when multiplying or dividing, the number of sig figs in the answer is determined by the quantity in the question that has the least number of sig figs. It's a little bit confusing, I know. I think an example problem might help clear this up. So let's say we're multiplying 3.201 times 1.2. So our answer would be 3.8. So when I talk about the answer in the question, I'm referring to this as the answer, and I'm referring to these as the question. So when multiplying or dividing, the number of sig figs in the answer, you can see this has 2 sig figs, is determined by the quantity in the question, so by one of these, that has the least number of sig figs. You can see that this number has 4 sig figs, and this number here has 2 sig figs. So the fact that this number has 2 sig figs limits us to an answer with 2 sig figs. Okay, so you probably understood this rule, but you're probably wondering, why are we doing this? So I'm going to attempt to illustrate that the best that I can. So let's multiply the same two numbers again. Remember we learned a little bit ago that a significant digit, a measurement that follows sig fig rules has all the certain digits plus one uncertain digit. That's what we see here. The uncertain digit is in red. So let's multiply these two numbers and see if we get 3.8. So keep in mind, if we multiply an uncertain number by an uncertain number, that will give us an uncertain number. If we multiply an uncertain number by a certain number, well, that still gives us an uncertain number. So we're going to carry this math through all the way, and all the numbers that are uncertain will be in red. So 2 times 2 is 4, 2 times 3 is 6. And then we need a placeholder. And this will be 1 times 1, and this is an uncertain number, so that will be 1, and that will also be uncertain. 1 times 0 is 0, 1 times 2 is 2, and 1 times 3 is 3. All right, let's add these up. An uncertain number plus a certain number gives us an uncertain number. Here's 2 uncertain numbers added up. Here's an uncertain number plus a certain number. And the same thing here, 6 plus 2 gives us an uncertain 8. And then this is 3. And then we count the number of decimal places, 1, 2, 3, 4. And then we slide it over 1, 2, 3, 4. So our answer is 3.8412. Now, if this 8 is an uncertain digit, if we're not even sure that this is an 8, how can we be sure that this is a 4, or that that's a 1, or that that's a 2? It just doesn't make any sense to try to report a number to this degree of precision if we're not even sure if this number is actually an 8. Remember, these are measurements we're multiplying together. These measurements would have been taken in a lab. So once again, our answer is 3.8. So we're going to be doing sig fig calculations all year. If you ever get to thinking, why are we doing this? Revisit this video, and this will show you how the uncertainty in a measurement is propagated through the calculation. So get that? These are measurements, and this is some uncertainty. And when you multiply these two numbers together, this uncertainty propagates all the way through the number. So the reason why we do sig figs is so our precision isn't just arbitrary. Our precision, our number here, it can only be this precise. So that's as far as we'll report it, is to the tenths place.